Vector calculus is being kind of a new subject, and it is a kind of a future when we see the multivariable calculus scenario. So multivariable calculus scenario where the kind of vector calculus being a newer concept that comes into the picture. So we have talked in and out all about the vector calculus. Now idea is that we would summarize. So what we have done, summarization in the sense that we have a kind of mustaqbil. Mustaqbil means future, that in calculus where the vector calculus, parameterized calculus is kind of play a pivotal role in the advanced calculus, or it would play a pivotal role in machine learning and artificial intelligence. If that is the case, then we have to put our brain in a sense that we have to pressurize our brain more in the towards the vector calculus. So we would summarize the vector calculus what we have taught, but what we learned is that power of vector, that is inbuilt direction, kind of sense of direction, and inbuilt magnitude, and then slope also. What is a vector? So vector is the energy which has a direction and then which has a magnitude. Vector is more on it. If we see the vector very closely, like if I say that I have xi plus yj and plus zk is the equation of vector, then first of all it shows three orthogonal energy. They coming in x, y and z direction, they meet at origin and they become one vector, that is xi plus yj plus zk, where strength of one vector is x, y and z. But altogether if they meet the orthogonal or orthogonally if they meet, the new vector has magnitude x square, y square, z square, square root. So this is what we have seen. You have to add. So this is what we have seen. But if I see closely xi plus yj plus zk as vector, then the gradient, the slope of this vector along x-axis, okay, then it is dz by dx, rate of change that we see in x, change that we see in z when there is a unit change along x-axis, rate of change that we see in z, the change we see in z when there is a unit change along x-axis, that is dz by dx. If that is true, then if it has component as z in the k direction and it has component x in the I direction, then z by x is dz by dx and z by y is dz by dy. So we have partial derivative, slope along x-axis, y-axis, and not only that, we have magnitude, we have direction. Everything we have inbuilt in the vector. What is kind of lacking is algebra. This is what we saw. We have been seeing, and this is something that is missing out there. I cannot say xi plus yj plus zk, where x, y, z are three independent components. Not possible, because anyway, x, y, z, they are separate component of the vector. Now again, three independent component out there is a kind of clumsy word. So vector calculus or parameterized vector or vector algebraic vector or parametric vector is a vector which where we push algebra inside it and make x component, y component, z component dependent upon a single independent variable, that is t. Algebraic equation is a independent variable fxyz where independent variable are xyz. Here if I have R is a vector. If R is a vector and it has three components, X component, Y component, and Z component, and these three components are dependent, then it should be dependent upon an independent variable, that is T. So T is the independent variable upon which X component, Y component, and Z component they depend upon. So all three places X, I, Y, J, and Z, K. So we will replace X with some algebraic equation or function of T, Y function of T, and Z function of T. So now I can say R is a vector that is function over T. On top of it, one arrow. RT equal to FTI plus GTK, GTJ plus HTK, HTH braces T, H bracket open, T bracket close, HT. So GT, FT, GT, HT. These three are X, Y, and Z component of the algebraic vector where independent component, the component is T and dependent component is FT, GT, and HT. So FTI plus GTJ plus HTK is RT. RT is the network. This is what we saw. We saw the interoperability also. Like if I have a vector that is 2I plus 3J plus 4K, and if I want algebraic equation through this vector, then we have, and where the xy is independent component and z with dependent component. So z equal to m1x plus m2y, where m1 and m2 are slope or change in z with respect to x and y. So z equal to dz by dx into x plus dz by dy into y. If that is true, then if I have a vector 2i plus 3j plus 4k, then we have z equal to 4y 2i plus 4y 3j, because z component is 4, y component is 3, and x component is 2. If that is true, then z equal to 4y 2i plus 4y 3j. So this is the algebraic equation. Now, now this is how vector and algebra, they are kind of tied together. If we kind of do some kind of manipulation, then it would result in like 3z equal to 2x plus, I'm sorry, 3z equal to 6x plus 4y, or 6x plus 4y minus z minus 3z equal to 0. So this is the equation of a surface. Surface in a sense that if I have xy plane, this is xy plane, and there are xy points on the plane. Fxy against each point fxy, I have z value. If I connect all the z, then it leads to a surface. Whereas altogether, if I take fxyz as a function, then it comes as a volume. But anyway, it is a surface equation. 6x plus 4y minus 3z equal to 0. So this is what we saw. Now, terminology comes that we are still in the static vector only, or we can say that scalar vector only, 2i plus 3j plus 4k. What about converting it to algebra? We push the algebra where the x component, that is 2, y component 3, and 4, that is z component. So these three components would be dependent upon a variable called t. So now I have equation called R is a vector. On top there is arrow equal to 2i plus 3t plus 2i plus 3j plus 4k. So what we are seeing here, that if there is a 2 change in I, then 3 change in j, and 4 change in k. That is true. Then if I consider x component as 2t, then y component becomes 3t, and z components become 4t, where t is independent component. If that is the case, then x component of r vector is 2t, 3t, and 4t, y component and z component. So now we have pushed algebra inside the inside the vector. Now we can call it parametric vector or algebraic vector. Parametric vector in the sense not 2t where t can vary. So 2t is gt, ft, 3t is gt, and 4t being ht. So r is the vector that is 2i plus 3j plus 4k. Now rt, r bracket open, t bracket close, on top of it arrow sign rt equal to 2ti plus 3tj plus 4t. Now it is a parametric vector equation or algebraic vector equation. Algebraic vector, we are giving the term. Probably it would not be available in any of the books. So keep watching us because we make things simple and pragmatic. So that is the concept. Okay, so now we have algebraic equation as 2ti, algebraic vector as 2ti plus 3tj plus 4tk. This is what we saw. Whereas same the surface equation, what we saw is 4 3z equal to 2 3z equal to 2x plus 4 3z, or z equal to 4 by 2x plus 4 by 3y. That is the algebraic equation. Now suppose that algebraic equation, if the vector or algebraic equation what we are talking about, the surface or vector line, the position vector, it passes through a point called 0, 0, 2. So it is something like this. If this is a vector, then we are giving offset in z direction as 0, 0, 2. Or if it is a surface, if it is a if it is a surface, then we are lifting it along the z-axis 0, 0, 2, 2. If that is the case, then algebraic equation would become z minus z0 equal to dz by dx x minus x0 in bracket x minus x0 plus dz by dy y minus y0 in bracket. So here it would become z minus 2 equal to 4 by 2 x plus 4 by 3 y. Since calling it, it is passing through point 002, but we lifted it from the origin point. It was passing the origin, we lifted from origin to 002. If that is the case in vector, if it is passing from origin 000, then it is a position vector. Now we have to lift it to 002. It is passing through 002, or it has interception in z axis as 2. If that is the case, what would be the vector equation? Algebraic equation, we deduce z minus z0 equal to dz by dx x minus x0 plus dz by dy y minus y0. So z minus 2 equal to 4 by 2 x plus 4 by 3 y. But in vector, whatever you do, vector will remain as position vector only. This is what we saw. If I lift it to, then if it starts from origin, then beginning point is 002. It ends at 234, then end point is now 236. 002 to 236, if I get the vector equation, then it will come again as 2, 3 and 4 only. So it is a more or less displacement vector because position vector. But what about algebraic vector where there is some hope? So we saw that if I have a RT vector as 2ti plus 3tj plus 4tk, then I can add a vector that is 0 vector. So 0i plus 0j plus 0k in braces plus 2ti plus 3ti plus 4tk. So there are two vectors now. One is the position vector and one is the vector from which it begins, 0 vector. We can add 0 vector. Addition is not an issue. This is what I will say. Subtraction is an issue as far as 0 is concerned. Multiplication is an issue and division is an issue. But addition is not an issue. So I have now a vector that is 0i plus 0j plus 0k plus 2ti plus 3tj plus 4tk. Two vector. One vector gives the start. Now start is origin. Instead of the origin start, now I have a start as 002. So we will replace 0i plus 0j plus 0k with 0I plus 0j plus 2k. Now I have equation of vector as 2k plus t and inside the braces 2I plus 3j plus 4k. So 2k is one vector and other vector is t and in braces 2I plus 3j plus 4k or 2ti plus 3tj plus 4k. These are the two vectors. Now let's see when t equal to 0, the initial vector was 0I plus 0j plus 0k plus t 2i plus 3j plus 4k. If t equal to 0, then we are at origin. Otherwise, t can I can produce. Here, if t equal to 0, then we are at 2k, means 002. This is what is required. But if t equal to 1, then we are at 2k plus 2k plus 1 vector at 2 plus 2I plus 3j plus 4k. Then 2I plus 3j plus 6k. Okay, so this vector starts at 002 and it ends at when t equal to 1, then 2, 3 and 6. This is what we want. Now we cannot kind of do any addition or subtraction. It's a different thing. 2k plus 2ti plus 3tj plus 4t. Now the vector equation is 2ti plus 3tj plus in braces 2 plus 4t bracket close k. So this is how we can place the offset. We can place the offset in the vector the way place offset in the algebraic equation. This is what we saw. So if I or we place offset or you say that now we are passing through a point that is 002. So if I have a vector that is RT, then if this vector passes through a point x0, y0, z0, then equation of the RT becomes x0i plus y0j plus z0k plus RT, whatever the RT is. So, whereas in algebraic equation it becomes z minus z0 equal to dz by dx x minus x0 dz by dy y minus y0. So this is what we saw. So we have now a full-fledged parametric vector, parameterization in vector, where we have algebra inside the vector and it passes through any point. This is what we saw. So we could make it, means it's possible. So vector is has power of algebra and vector has power of direction, vector has power of magnitude quickly, and then it has dz by dx, dz by dy, slope along this and that means partial derivative. Everything is available there. Now calculus is ready to do manipulation on vector algebra. This is what we saw. If that is true, and if this is the displacement vector that is RT, then dr by dt is velocity. d2r by dt square is acceleration vector. This is what we see. We saw. So if displacement vector is r, if displacement vector is r sine r cos pi t. This example we take that if I have a circle and someone is running around the circle in the parameter, or a boy, small boy, he is playing on a kind of a big toy that we see in park and those regions where he sit on a chair and he rotates in a circle. So there, the equation like in first second, he is at one location and second, I mean, at 0th time, he is at one location, whereas in first second, he is at the pi distance. Then again, second, he is at the beginning only. Then third second. If this is the way he is rotating, then equation of this circle would be r cos pi t, because at t equal to 0, it is 0, t equal to 1, then it is pi. R cos pi t, r sin pi t. So now if the RT equal to RT, so I'd rather than R cos pi t, I would say it as A cos pi t. A is a radius. A cos pi t I plus a sine pi t j. Now, if I calculate the velocity vector, then it will become like pi minus a pi sine pi t I plus a pi cos pi t. Now, the displacement vector is a pi cos pi t I plus a pi sine pi t j, whereas the differentiated, that is velocity vector, is minus a pi, that was a cos pi t I plus a sine pi t j, that is displacement, whereas velocity is minus a pi sine pi t I plus a pi cos pi t j. If we do dot product of these two, it would result in 0. So if I have a displacement vector that is in a curve, not in a straight line, then velocity is perpendicular to it. So it will be tangential. So if I have a circle like this, if I have a circle like this, and this is center and there is a circle, then displacement vector is radial every point. Whereas if this is the arc, the velocity vector is tangential. Center and then arc of a circle, then displacement vector from center, it is radial. Whereas if this is the arc of the circle, then tangent is the velocity vector. If I go with d2r by dt square acceleration, then it would result again in minus a pi square cos pi t I minus a pi square sine pi t j. So if I take out minus a pi square minus pi square, then it will become same as the displacement vector, a cos pi t I plus a sine pi t j. So acceleration and displacement vector looks like they are in same direction, but one is negative, means they belong to kind of a similar vector, but they are in opposite direction. So if this is a circle and this is center, then this radial is displacement vector, then acceleration vector is toward the center, same direction, opposite. Whereas velocity vector is tangential at the arc of the circle. This is what we saw. So if keep do the differentiation, it will tilt 90 degrees. So these are the velocity vector and acceleration vector that we calculated. The biggest and most amazing part here is we can calculate the arc length. But anyway, the displacement vector, velocity vector and acceleration vector, when they are related to each other orthogonally, but that is only when the line, the vector, what we have seen, that is a pi cos t I, a pi sin t j plus in between, that is a curve. If it is a straight line, then the displacement vector, velocity vector and acceleration vector, they would be in the same direction. Like if I say I have a equation that is t to the power 3, and inside that I have t to the power 3 I plus t to the power 3 j. That is the equation. So if I calculate the kind of velocity, then it will become 2t square, 3t square I plus 3t square j. Certainly they are in the same direction. They are not orthogonal to each other. If I calculate acceleration, then it would result in 6ti plus 6tj. Then again acceleration in same direction. If it is a straight line, then displacement, velocity and acceleration are in same direction. But if it is a curve, then velocity is tangential, then again the acceleration is negative to the displacement vector. Anyway, but if I have a displacement vector like a cos pi t I plus a sin pi t j, then can we calculate the parameter of the curve, length of the curve, parameter of a circle, length of the curve. So what is the length of the curve? If I have a velocity, if A person starts from a point and he is running and he has a velocity that at any moment from the beginning, what is the displacement he has traveled, then we have to do the addition. Velocity is nothing but rate of change in the displacement or displacement per unit of time how much it is changing. If that is the case, if I multiply by the time, I get the total displacement. So addition is integration. Only thing is that addition through the area in the graph is the integration. So if I have a velocity vector and if I calculate the integration, I get back the displacement. So if I want the length of the curve, then I do the differentiation, calculate the magnitude of the differentiated vector, and that you do the integration. If that is the case, you get back the length of the arc. Amazing. We'll see later. Line means vector line integration and flux integration. That will all will happen in the vector calculus through the parameterized vector. Amazing. Means vector calculus for now being we can consider this as more power to the algebraic calculus. Now, if I have pi cos ti plus pi sin tj, if I do the calculate the velocity vector, that will result in minus, that is a cos pi ti plus a sin pi tj. If I calculate the velocity vector minus a pi sin pi ti plus a pi cos pi tj. So now I have to calculate the magnitude of this vector. That will come as pi square a square, pi square a square, sin square pi t plus pi square a square, cos square pi t, square root. Now I have to integrate. So this is the velocity vector. I have to integrate it from 0 to 2 pi if I want to calculate the perimeter. So minus a square pi square minus, I'm sorry, minus a pi cos pi sin pi t whole square plus a pi cos pi t whole square square. So that will come out as a square plus pi square in bracket cos square pi t plus sin square pi t square root. Then that will become 1, and then these kind of uh, pi square pi square a square pi square a square plus pi square a square again. So now we have to take out the square root of it. So that will come to pi a whole. So pi a, if I integrate pi a with dt, then it will become pi a t. So if I give the limit as 0 to 2 pi, then it will become pi in, then it will become pi into a into 2 pi. Okay, so the kind of its parameter is pi into a into 2 pi. Now the equation what we had taken was a cos pi ti plus a sin pi tj. Now remove this pi. So a cos ti plus a sin tj, where a is the radius. If that is the case, then pi is gone. So in that sense, I have the parameter as a into 2 pi. So if I replace a with r, then 2 pi r. So 2 pi r is the parameter of a circle. Now I can change it in ellipse or I can change to any equation, and I have to calculate the velocity vector, get the magnitude of the velocity vector through Pythagoras theorem, a square plus b square square root. Now do the integration and then get the length of the curve. Like if I have equation like 2 cos ti plus sin tj, it is like of ellipse, then it will become 2 square, then it will become minus 2 sin ti plus cos tj. Now minus 2 sin t minus 2 sin t square plus cos square t square root dt integration 0 to 2 pi. So then it will come as kind of 4 4 sin square t plus cos square t square root dt. Anyone calculate the integration. Okay, and then limit is 0 to 2 pi. We can calculate the parameter of a ellipse. So this is what we saw as far as velocity, acceleration, and these things are concerned. Now we also saw that, okay, so when we are seeing different things, we also saw that if I have a parametric vector and that is a kind of a function over t, then two vectors they collide each other or not, or if they don't collide, if they intersect each other or not. So two vectors which are in a function of t, and if I equate these two x component, if we equate y component, if we equate z component of two vector, if we equate, and we see that x component both are at t. If they collide each other, then both at t point, both x component are same. So we get the t with x, y, and z. If t comes same, then they hit each other. Or if they don't hit each other, they pass through. Then at t1 time they pass through one point, and same point they another pass at t2. If that is the case, then x component both has t1 and t2, y component both has t1 and t2. So two variable I have to find where we have two equations. In that case, we can find t1 and t2. In z component, t1 and t2 will place with this t1, t2, and if see it satisfies. If it satisfies, then they cross each other. That means innumerous. There are numerous that is advantage of vector algebraic vector calculus. Anyway, post that we came to vector field. Vector field in a sense that if I have a algebraic equation and I do the partial derivation of algebraic equation in term of x, y, and z, then we get a vector that is called gradient vector. Like if I have a function called fxyz, then dfxyz by dx, dfxyz by z, dy, and dfxyz dz. Okay, so dfxyz by dx I plus dfxyz by dy j plus dfxyz by dz k, that becomes the gradient vector. This gradient vector, we call it velocity vector. It can be now velocity vector, acceleration vector, vector field, magnetic field, electromagnetic field, electrical field, whatever. So that concept we saw through vector field. Vector field is a vector where is like a vector, but each component of the vector, if it is a 3D, then there are three components. So vector field, three components. Each component is function over x, y, z. So if I call three components as f1, f2, f3, or f1i plus f2j plus f3k, then f1 is function over xyz, f2 is function over xyz, and f3 is function over xyz. Altogether, I have a vector field that is capital F, not a smaller. Capital F, on top of it there is a vector sign, arrow sign, and it is a function over xyz. So I have a vector field capital F function over xyz where it has three components f1, f2, f3, f1i, f2j, and f3k, where f1, f2, f3 again they are function over xyz. Now if this is the vector field like velocity field we saw, if I calculate the integration of it, it would result back in either algebra because we differentiated it, or it will result back in the parametric vector, or we call it as a flow line. So flow line is a line, or the arc length. Flow line is a line that talk about the distances through which it is flowing. Okay, so vector field is a, we talked about, it's a like a vector factory where it is a function over xyz. We keep changing xyz, then we are keep changing f1, f2, f3. So it would keep generating new vector at each xyz point. So it's a vector field is a vector which is a function over xyz. If it is a function over xyz, then it would keep generating vector. So it is a vector field, vector factory. Depending upon each x comma y comma z, it would develop a vector. So it is a vector factory. Now if I have a vector factory, then at each point I have a separate vector. If I have 1000 points xyz, then at each point I have a separate vectors. That is vector field. Now if I integrate, then I get the actual direction, actual displacement, that is flow line. So if vector field, if I need to get the flow line or parameterized vector, then I have to integrate with t. So x, y, z I cannot integrate with the t. So if any f1, f2, f3 is constant, then I can get the x component of the RT parametric vector or flow line as function of t. Now wherever x is there, this x we can replace and we can get the parametric vector. The parametric vector has to be in function of t. But if f1, f2, f3 all together there is x, y, z, then integration of x, y, z with the dt to get the parametric vector is not possible. So then we went to Euler estimation, where we saw that if RT is a vector and it is independent component is t along x-axis, t is along x-axis, and there is t1 and t2. At t1 it is r1t and t2 it is r2t. Then r2t minus r1t is delta r. So R2t equal to R2t minus R1t equal to delta R. So R2t equal to R1t plus delta R. If delta R is the vertical and delta T, that is T2 minus T1, is the horizontal, and if I know the vertical vector field we called it as velocity vector, means differentiated one. So differentiation is nothing but slope. So if I multiply slope with the x-axis, we get the vertical. This is the algebraic fundamental. So R2t equal to R1t plus delta R. Delta R, that is the vertical, I can replace with delta t into vector field F. So R2t equal to R1t plus delta t F. F function over R1t, function over xyz. Xyz means xt, yt, zt. Means xt, yt, zt are three component of R parametric vector. So R2 equal to R1 plus delta T F xyz, function over xyz, F is capital. Xyz I can replace with xt, yt, zt, means RT. RT means R1t. So R2t equal to R1t plus delta T vector field of R1t. So R2t is completely, now we can calculate when we have data like R1t, vector field and delta t. So if I have one point, the point through which our parametric vector passes through, that is R1t, and that point I can place in the vector field, and delta t, how much delta t we have taken, then R2 we can calculate. So R2 we can calculate if I know the R1. R1 means the point through which it passes, and that point I can satisfy in the vector field, and delta t if I place, then I get R2. So R2 I can get from R1. Now R3 I can get from R2. R4 I can get from R3. So Rn plus 1 t equal to Rn plus delta t f Rnt. So this is Euler estimation, and we can get the flow line parametric vector points against each t. So that vector we can calculate. If I get the flow line vector parametric vector, I can calculate the magnitude, direction, and partial derivative also. Okay, so this is something that we summarized in a kind of fashion, that is parametric vector or the algebraic vector calculus. Okay, so we will see lot of things in vector in future.